In this example, we are given a saturated soil that has a dry unit weight of 16.2 kilonewtons per meter cubed, and we're being asked to compute the saturated unit weight, the specific gravity, and the void ratio, also given a moisture content of 20%. So this is also right out of the book, example 3.4, but again, I'm going to do this differently than what the book does. We are going to fully draw the phase diagram, and we will see we get the same answers that the example in the book does, but I do not want you to solve these problems like what the textbook is doing. I want you to solve them the way I'm showing you, which is drawing and fully populating a phase diagram from the beginning, okay? So we're going to start with a solution here. And the first thing we need to note is we are not given any non-ratio values. So I'm going to say, since we do not have any non-ratio values, we must assume something is 1, okay? And if you remember our discussions, we've said that we have some flexibility on what we assume equals 1, but generally speaking, I like to assume either a volume of solids is equal to 1 or a total volume is equal to 1. Making one of those two assumptions will usually make your calculations go a little smoother, but even between those two options, it's good to assume something is equal to 1 strategically, okay? So if we look at our given information here, we're given a dry unit weight and we're given a moisture content, okay? So what do you think would be a good assumption of something equals to 1 based on what we're given in the example? So maybe pause the video and think about it for a minute, and then, hit play and I'll be saying it right now, I guess. So I'm going to say, since we are given gamma dry, it is most efficient to assume total volume equals 1 cubic meter. Total volume, okay? Now, here's why. Gamma dry is equal to the weight of solids over total volume, right? So if we assume total volume is equal to 1, and we know gamma dry, that's given to us in the problem statement, what can we immediately calculate? We can immediately calculate the weight of soil solids, okay? So that'll make our lives go a little easier, okay? So let's go ahead and draw our generic phase diagram, okay? So we've got air, solids, and water, and I'm going to put the volume over here, cubic meters, and then I'm going to put the weight over here, and we can keep our weight in, how about we just use kilonewtons, okay? And if we have our volume over here, we got, of course, volume of air, volume of solids, volume of, oh man, let's rearrange that. I typically do air, water, solids. I don't know what's gotten into me of flipping these around. Volume of water, volume of solids, and then the air and the water together make up the volume of voids, and then obviously all together we're going to have a total volume, okay? And then on the weight side, we've got weight of water, weight of solids, and total weight, okay? So again, we know nothing right now. We are making an assumption total volume was equal to 1 cubic meter, so we can put that on the far left as 1 right here, all right? And now we can apply that unit weight definition. Dry unit weight is equal to weight of solids over total volume, which is equal to weight of solids over 1 cubic meter. So the weight of solids ends up being equal to what? Well, that's just 16.2 kilonewtons, right? The cubic meters multiplies up here, and it cancels with the cubic meters in the denominator of the 16.2 kilonewtons per cubic meter. And so we are left with a total weight, a weight of solids of 16.2 kilonewtons, okay? So what else can we do? What else can we start maybe piecing together? Well, we know we were given a moisture content of 20%, right? Moisture content equals 20%. So how about we use that? We know that the definition of moisture content is weight of water over weight of soil solids. So put a little arrow here. I'm going to say 0.2. That's my 20% as a decimal, is equal to my weight of water over my weight of soil solids that I just figured out. So then I can calculate my weight of water is 0.2 times 16.2. So I get 3.24 kilonewtons as my weight of water, and I can populate that in my phase diagram now, 3.24. Now that I have my weight of water and weight of soil solids, I can add them together to get my total weight, can't I? And so adding those two together, what do I get for total weight? Well, 3.24 plus 16.2, and I get 19.44 kilonewtons as my total weight, okay? So if you look at this carefully, the whole weight side is finished now, right? We're done with the weight side. So how do we go from the weight side and translate over to the volume side? Well, weight and volume are related by unit weight, okay? So let's go ahead and do that. We can relate the volume of water and the weight of water through the unit weight of water, and then we can relate the volume of solids and the weight of solids through either a specific gravity value or density or unit weight of some sort, okay? So let's go ahead and let's start with water. How about that? That's the easier one to do because we know the unit weight of water, right? So we're going to say the unit weight of water is the weight of water over the volume of water, okay? And we can do some rearranging, and we'll say the volume of water is the unit weight of water times the weight of water. And so the volume of water is, what's the unit weight of water? 9.81 kilonewtons per meter cubed. And then my weight of water that I just figured out was look at that. I made an algebra boo-boo. What was I thinking? Maybe you caught it. Volume of water. Volume of water is weight of water, divided by unit weight of water. I don't know what I was thinking. Okay. So volume of water is 3.24 kilonewtons divided by 9.81 kilonewtons per meter cubed. And let's see what we get. 3.24 divided by 9.81. And we get 0.33 cubic meters, okay? If you want to take that out maybe to a few more sig figs, that's really 0.3303 cubic meters, okay? So let's populate that side now. We have 0.3303 as our volume of water, okay? Now, what can we get next? What can we get next? Well, if you look at our volume dimension lines, okay, if we look at our volume dimension lines, can we combine or repackage anything conveniently? So at first glance, it seems like there's not much we can do right now. However, what did the first line of the problem statement tell us? A saturated soil, okay? So what does that imply? Let's write this down. I'm going to change colors here. I'm going to say, since the soil is saturated, then the volume of voids is the same as what? The volume of water, okay? So in our phase diagram, the volume of air is equal to what? 0, okay? Volume of air is 0 since all the voids are filled with water. That's what the word saturated means, okay? So now what we can do is we can say the volume of voids also equals 0.3303, okay? Now that we have recognized that, can we calculate the volume of soil solids? Yes, absolutely. We can calculate this volume of soil solids. It's total volume minus volume of voids, right? So we're going to say volume of soil solids is total volume minus volume of voids. So that's 1 cubic meter minus 0.3303 cubic meters. And what do we end up getting? We get 0.6, basically 0.67 cubic meters, okay? And so we can populate that right here, 0.67. Now, here's another way we can draw this phase diagram, okay? We could just as easily draw this phase diagram like this. You could just say water and soil solids here, okay? And then, of course, on the volume side, cubic meters, and then you have the weight side in kilonewtons. So over here, you've got volume of voids equals volume of water, and we have volume of solids, and then we have total volume, and then, of course, we've got weight of water, weight of solids, and total weight. Now, on a homework assignment or a test problem, if you drew this phase diagram with only 2 phases at the very beginning, that's perfectly fine with me. If you recognize volume of voids and volume of water are the same when the soil is saturated, you got to look for that phrasing. That's the key phrasing there, saturated soil. And you want to go straight to this 2-phase diagram, that's perfectly fine with me, okay? I just started with a 3-phase diagram so we can kind of lead up to the fact that this is the situation we have. Volume of air is 0 and volume of voids equals the volume of water, okay? So now this thing is fully populated, right? This diagram is fully populated. So are we ready to calculate everything that we're being asked for? Yeah, absolutely. So we're going to say the saturated unit weight. Remember, what is saturated unit weight? Unit weight, look back in your notes, is a special case of total unit weight. It's still total weight over total volume when the degree of saturation is equal to 1.0. That's what saturated means. So gamma sat equals, our total weight was, what did we calculate that as? 19.44 divided by 1, okay? So we're going to say 19.44 kilonewtons divided by 1 cubic meter. Of course, that's 19.44 kilonewtons per cubic meter. That's one of your answers that you would box in. Specific gravity of soil solids. That's going to be the unit weight of soil solids divided by the unit weight of water, okay? And I can say the unit weight of soil solids is the weight of soil solids divided by the volume of soil solids. Again, that's all over unit weight of water. Doing some algebra repackaging, I've got weight of soil solids divided by unit weight of water times volume of soil solids. And I have all of these values. My weight of soil solids was 16.2 kilonewtons. The unit weight of water is 9.81 kilonewtons per meter cubed. And my volume of soil solids that I had just calculated was 0.67 cubic meters. So let's write that here, 0.67 cubic meters. And notice that all my units end up canceling. So 16.2 divided by 9.81 times 0.67. And I get a specific gravity of 2.46. And that's one of my answers. And then finally, void ratio is volume of voids over volume of solids. The volume of voids was the same as the volume of water in this case. So That's 0.3303 cubic meters divided by the volume of solids, 0.67 cubic meters. So 0.3303 divided by 0.67, and I get a void ratio of 0.49, okay? So again, the moral of this example is look for that keyword saturated. If you have a saturated soil sample, that means S is equal to 1. And if you want to, you can immediately draw a phase diagram with two components, just the water and the solids. And note that the volume of voids is equal to the volume of water since the voids are all full of water, okay? But again, the reason why I started with a three-phase system just to kind of lead us up to the fact that the volume of air would end up being 0, okay? So that's why we started with the three-phase system, but we could have just as easily started with a two-phase system diagram.